So let's do a quick example with some theorems we learned in 10.5. So we know that arc BC has a measure of 84 degrees and we're looking for angle A to start. So if we look at angle A compared to the outer circle, it looks to me like angle A is an inscribed angle. It's got a vertex on the circle. So that theorem tells us that the angle here should be half of arc BC, so that should be 42 degrees. We also know that BA is tangent to circle O, to the inner circle. So if we draw a radius from OD to a point of tangency, then we know that we get a right angle there. So if we know that angle A is 42 degrees, and we're looking for the angle in here, we know that that angle is 48 degrees. Now, knowing angle DOE is helpful, because we were looking for arc DE. So angle DOE, that's a central angle, so it has the same measure as arc DE, so that means arc DE is also 48 degrees. The last thing we want to find is arc DF. So we can do this in a number of different ways, but I think the easiest way is to recognize that FE is a diameter. So arc FDE all the way around the semicircle should be 180. So DF should be 180 minus arc DE, so that's 132. So we can check to make sure that all of this makes sense. If we look at angle A again, and then we look at that smaller circle, if you'll notice we have a tangent secant angle. So a tangent secant angle says angle A should be 1/2 the difference between DF and DE. So let's just make sure that this works. So angle A, which is 42, should be 1/2 132 minus 48. So 132 minus 48 is 84, and yep, it does work out. All set.